All right, here we go. Limits 1 through 16. Here's the first page. Number 1, mad easy. We're just going to throw in 3. So this is going to equal 2/3 times 3 squared plus 3 times 3. And that's going to equal 3 squared is just 9. 9 divided by 3 is going to be 3. And then 3 times 2 is going to be 6. And then 3 times 3, of course, is 9. The limit equals 15. Easy. Number 2, plug it in, see what happens. If I plug in 4, I'm going to end up with 0 at the top and then also 0 at the bottom. Indeterminate form. Okay, we don't know what this means, but it indicates to us as calc students that we have to do some factoring. So I'm going to write the limit as t approaches 4. The numerator, there's nothing to simplify. Down here, difference of squares. Recall that a squared minus b squared equals a plus b times a minus b. So we're just going to do t minus 4 times t plus 4. All right. Oh, what do you know? T minus 4, they cancel. Okay, it's a removable discontinuity. Now that we have this, we can just plug in. We have 1 at the top. We'll plug in 4 for t at the bottom, and then we end up with 1 over 4 plus 4, which of course is 1/8. Mad easy. Number 3. This one, if we plugged in, we're going to end up with 30 over 0 if you plug in -3. All right, that is not an indeterminate form. Okay, that tells us that there's an explosion to positive or negative infinity. Okay, division by 0 creates that asymptotic behavior. So what that means is we're going to have to check the limit from the left and the right of -3. And then we're going to plug in values and then see which way it's shooting up, all right, or down. Okay, so I'm going to factor this first. So instead of an equal sign, I'm just going to do an arrow just so I can get my thoughts out. So if you factor this, this is going to be x minus 3 times x minus 2 all over 2 times x plus 3. All right, we're just factoring the quadratic and then pulling out 2 in the linear denominator. All right, just makes things easier when you plug in. So let's go from the left. Since it's -3 from the left, that would be something like -3.1, and then from the right, that'll be something like -2.9. Then we'll just plug it in, see what happens for the signs. So on this one, we'll do -3.1 minus 3 times the quantity -3.1 minus 2 all over 2 times -3.1 plus 3. And we're just going to check to see what kind of signs we have. All right, let's see. So at the top, if we do -3.1 minus 3, that's some negative number. And then -3.1 minus 2 is another negative number. So the top becomes positive. And then the bottom, we're going to have -3.1 plus 3 is going to stay negative. And then times 2 would still give us negative. So the bottom is negative. So we're going to end up with a positive over a negative. Therefore, this is going to negative infinity. And then same idea for the right-hand limit. We'll just plug it in, check the signs. So we're going to do -2.9 minus 3 times -2.9 minus 2 all over 2 times the quantity -2.9 plus 3, and we'll check the signs again. So -2.9 minus 3 is going to be some negative number. -2.9 minus 2, another negative number. And then down here, it's going to be -2.9 plus 3, which is going to be positive, and then times 2 is going to be positive. So the bottom is positive. So the numerator was positive, the denominator was positive. This is shooting to positive infinity. All right, so as far as answering the question, we're going to say the limit as x approaches -3 of the function x squared minus 5x plus 6 over 2x plus 6 does not exist. All right, the key in this one is knowing this. This is not an indeterminate form. It's an explosion to positive or negative infinity. So that's why we have to check from the left and the right. All right. Okay, number 4. A little bit of trig here. All right, nothing crazy. We're just going to plug in pi and see what happens. So we're going to do sine squared of pi minus 3 times cosine of pi. All right, so I'm just going to rewrite this. I like to write this, so we're going to do sine of pi, quantity squared, that's the same thing, minus 3 times cosine of pi. That, to me, just looks a little bit clearer. Okay, all right, so we know that from the unit circle that pi is equal to 180 degrees. Okay, so pi radians is 180 degrees. This point right here at 180, or pi radians, is going to be -1 comma 0. Okay, so the sine is y, so sine is going to be 0, and then cosine is going to be -1. All right, and that's basically what we need to know. So if I start to kind of simplify this here, sine of pi is just 0, square that, minus 3 times cosine of pi is just -1. So we're going to end up with 0 plus 3 for a total of 3. Okay, so the limit for number 4 equals to 3. All right, moving right along. We have 5, the limit as x goes to 2 of this cubic function. So let's see, so we're going to have to factor. So if I was to plug in 2, I would end up with 0 over 0. That indicates we need to do some factoring. Since this is cubic, I like to identify my a and b terms. So in this case, the cubic root of x cubed is just going to be x, and then b is going to act as the cubic root of 8, which is just 2. Then we're going to just plug in the formula. So because I haven't evaluated yet, I'm going to write the limit again. But instead of x cubed minus 8, I'm going to take the factored form of that, which is going to be x minus 2 times x squared plus 2x plus 4, all over just x minus 2 at the bottom. Okay, and as you can anticipate, because this is an academic calculus problem, these factors will cancel, so we get rid of the continuity, the discontinuity rather. And now we can plug in, and we're going to be happy time. So now let's just plug in the limit, which is 2. So we're going to do 2 squared plus 2 times 2 plus 4, which is going to give you 4 plus 4 plus 4. Don't make any Wendy's jokes, and that total is going to be 12. All right, last one for this page, number 6. A little bit of trig here as well. Nothing difficult. The only thing you need to know is that tangent of theta is rewritten as sine of theta over cosine of theta. All right, you don't actually need it for this problem, but eventually we're going to start to use this a ton. Okay, so tangent is just sine over cosine. So I'm going to rewrite this limit. So this is going to equal the limit as theta goes to pi over 3. Instead of tangent, I'm going to do sine of theta over cosine of theta, all over theta squared. All right, so now I'm going to plug things in. So I'm going to do sine of pi over 3 over cosine of pi over 3 over pi over 3 squared. Okay, so we have a little bit of simplifying to do. All right, so now I'm just going to get rid of this so I have more room. So now let's actually calculate these values. So I'm over here at pi over 3. Okay, so that's going to be this part of the unit circle. And the values here are going to be 1/2 for cosine, or the x value, and the y value, or the sine, is going to be the square root of 3 over 2. All right, so now I'm going to start to replace some things. So if we start to replace sine of pi over 3, that's just going to be, that's just going to be the square root of 3 divided by 2 over, now I'm going to plug in this, or kind of simplify this rather, cosine of pi over 3 is 1 over 2. I don't need the unit circle anymore, I have my appropriate coordinates, all over pi squared over 3 squared is going to be 9. Okay, so we see a lot of crazy fractions happening here. So we're just going to simplify this. Now remember that when you're dividing fractions, you can just multiply by the reciprocal of the denominator. All right, I know in middle school they do like keep, flip, change, or something like that, or some other fancy language. Essentially, we're just going to rewrite the division as multiplication, and it's going to be a little bit more simple. So I'm just going to focus on this part first. Let's just clean this up a little bit. All right, so here we go. We're going to do root 3 over 2. Let's multiply by the reciprocal, which is 2 over 1. And then at the bottom, we have pi squared over 9. All right, now, of course, these 2's are going to cancel. So our numerator becomes a little more simple. It's just root 3 over pi squared over 9. And now we're going to multiply by the reciprocal again, all right? So we have the square root of 3 times the reciprocal would be 9 over pi squared. And we're just going to write this in a more standard form. We'll put the constant first, and then the irrational constant next, and then pi squared, all right, over pi squared. So that's your final answer. I know it doesn't look like an actual number because you have some irrational business happening here, but 9 root 3 over pi squared is the final answer. All right, so nothing difficult. So you have to know a couple things. You need to know the algebra of flipping for the reciprocal to turn division into multiplication, and you got to know the unit circle, and you also needed to know that tangent is sine over cosine. All right, but if you have that knowledge, this one shouldn't have been too bad. All right, I'll do the next page in a minute.